All right, we're going to talk about some special right triangles here and some right triangle trigonometry. That's where we're headed, so I want to give you a little bit of a preview of what's going on here. All right, so our first order of business is we want to look at some special right triangles. We're going to have a couple special right triangles. Here we got an equilateral triangle. We already know about that. There's no right triangle there. What? Well, but what about if we want to find the height of this? If we want to find the height of this, well, we've got to think about drawing that height in, and we get a nice right triangle called the 30, 60, 90 right triangle. That triangle is going to be really useful. What if we shrink it down? We get another 30, 60, 90 right triangle. And if we keep shrinking, we get more and more and more. We can have 30, 60, 90 triangles all day long. And what do we know? We know they're all similar because they have a 30, they have a 60, so we got some similar triangles. And we're going to find out that these have special ratios. Turns out that they've got a ratio of 1 to 2 and 1 to square root of 3. And we'll see where that comes from. And if you want to make another special right triangle, just multiply it by some number and we'll have some ratio, a larger special right triangle. These right triangles are really useful for finding quick lengths. Maybe you're welding together some frame. Maybe you're building a house. You got to find what these lengths are. Maybe you're building some custom bicycle or some piece of art. Well, 30, 60, 90 triangles and what we'll see in a moment, 45, 45, 90 triangles can be a very powerful tool so that you can find those right angles and those right lengths. So that's our 30, 60, 90. What if we take a square and we cut it in half? So here we've got a square. We're going to chop that thing in half. And when we chop that thing in half, we get a 45, 45, 90 triangle. This 45, 45, 90 triangle is a very useful triangle as well. And it comes out to have sides that are 1 because it's half of a square and a diagonal that's the square root of 2. So you want to find a larger one. Maybe you don't want it to be 1, you want it to be 5. We'll multiply everything by 5. You've got another 45, 45, 90. Very useful tool, very useful ratio. We're going to see how that will help us and be applicable in lots of situations. Well, those are special right triangles. Well, what if we have a right triangle that's not so special like this guy right here? What if we say we got a right triangle, we know it's got a 90-degree angle, but it's a 40-degree angle here? Well, we can still find these sides using a new tool called trigonometry, and that's going to be pretty interesting stuff. We can also use trigonometry to find missing angles. Maybe we got two sides. Yeah, Pythagorean theorem will help us find this side, but Pythagorean theorem will not help us find this angle. So we'll need some trigonometry. Trigonometry is just 3 special ratios: sine, cosine, and tangent. That's the key to right triangle trigonometry. You can call it SOHCAHTOA. That'll be a nice way to remember how to find sine, cosine, and tangent. Trigonometry, a powerful tool, useful when we want to find angles, we want to find sides. If we're designing something, building something, or we want to find the slope of a road, we can get that angle, a little distance, and you can know lots of information about angles and anything dealing with angles in your right triangle situation. So, once again, we're headed towards special right triangles, our 30, 60, 90, and our 45, 45, 90, and our triangles that are right but not so special. Then we can use our right triangle trigonometry. That's where we're headed. Now you can see. So let's dive in and talk about some special right triangles.